Problem 3 from section 5.1. So this says for the function that we see here, find the critical numbers and then use the second derivative test to determine whether the critical numbers lead to a relative maximum or a relative minimum. Okay, so first thing we want to do is find those critical numbers. So for that we need the first derivative, so we've got it there. Then notice that we can factor out a 2x from there. So we get 2x, leaving us with 3x and minus 4. Set that equal to 0 to find these critical numbers. So we're going to get x, well, 2x is equal to 0, and we get 3x minus 4 equals 0. So we've got two critical numbers. X equals 0 is one of them, and x equals 4/3 is the other one. Okay, so the second derivative test is another way to tell us whether we have a minimum or maximum value in a function. Recall that we had the first derivative test, which was the table, and the way we determined whether we had a min or max is we checked to see if the sign of the derivative was changing at the critical number. Here we don't have to bother with that. We take the second derivative of the function, and we're going to use that to determine whether we have a min or max. So the second derivative, there's the first derivative. The second derivative will be 12x minus 8. Okay? So what I want to do is take these two critical numbers and just plug them in here into this function. So I'm going to get f double prime of 0. And notice that f double prime of 0 is negative 8. That's a number that is less than 0. And then further notice that f double prime of 4/3. Now I don't really care what it actually is, although I guess we can figure that out. 4/3, if I plug that in there, the 3 will be divided, the 12 will be divided by the 3. I'll get 4 times 4 is 16 minus 8 is 8. So that's greater than 0. Okay, this is really all that matters when we're talking about the second derivative test, is what sign do these critical numbers have when we plug them into the second derivative. Okay, so what does this tell us? This tells us that the function is concave down, f is concave down at the critical number, at x equals 0. So, and remember that x equals 0 was critical. So that means the first derivative was 0 and the second derivative is negative. What conclusion can we draw from that? That means that the function or we have a maximum value at x equals 0. So there's a maximum at x equals 0. Okay? So why do we have a maximum at x equals 0? Well, since it's critical, this is kind of what's happening on our graph here. It's critical means that it's flattening out at that value. That's what the first derivative being 0 means. So if it's flat, if its first derivative is 0, it means we've got a horizontal tangent line. And if it's concave down, this is what it looks like. Tangent line, horizontal. That's what we get from the fact that it's critical. And the fact that it's concave down means that we must have a maximum there. Okay? Very similar here. What does this mean? The fact that this is positive. Well, that means it's concave up. So f is concave up at this other critical number of x equals 4/3. So what does that tell us? Since it's concave up, it's kind of the opposite of that. So we've got a minimum at x equals 4/3. Okay, and again, if you think about what we're talking about here, the fact that 4/3 is critical means that we would have a horizontal tangent line at that value, at 4/3. So there's our horizontal tangent line. And the fact that it's concave up means that we must have a minimum value there. Okay, and the question says, use the second derivative test to decide whether the critical numbers lead to relative maximum or relative minimum values. So it doesn't actually ask us to find these min and max values, so we're actually done. This critical number at x equals 0 led to a maximum value, and this critical number at x equals 4/3, that led to a minimum value at 4/3. Okay? So that's what the second derivative test tells us. And really this test, as you can kind of tell, it's a little bit easier than the first derivative test. All we really had to do was find the second derivative and plug those two critical numbers right into the second derivative, and then all we cared about was the sign here, the sign of the second derivative at the critical number. All we needed to decide whether we had a min or max value. Of course, the second derivative test is not going to be particularly easier if it's difficult to find the second derivative. Some of these functions that we're looking at, it's kind of hard to find that second derivative. So if the second derivative is difficult to find, you might not want to use this second derivative test. You might just want to stick with the first derivative test. But if it is easy to find as it was here, the second derivative test is actually a little bit easier than the first derivative test when we're trying to determine min and max values.